My name is Charles Chapkanya. I work for Greencon greenhouse suppliers. Our main thrust or our main business is to do greenhouses, large scale, small scale, medium scale, but in the endeavor to add it to our products, and at the same time looking at the nutrition part of the requirements of a human being, we thought it would be best for us to involve ourselves in fish production. So instead, what we have seen is we have got large-scale farmers, and we want to deal with small-scale farmers. It happens now that you find that even in towns, people are going hungry, and we thought people have got big yards which they can use to produce fish. Our fish system requires only a 6 meter by 6 meter. So we construct a 6 meter by 6 meter tunnel, and the system fits in there. So even in the highly ventilated suburb, if you have got a 6 by 6 meter vacant space, you can actually do fish. The fish we want to grow here is called the Nile tilapia or the Kariba bream. Rather, let's call it Kariba bream so that everyone else would understand. It's the Kariba bream. It's mainly grown or in Kariba, but now we are doing it in a greenhouse because all of us cannot live in Kariba. We rather wanted to bring Kariba to Harare, to Mutare, to Chinoi, wherever you would want, by putting a tunnel. That is the whole essence of putting it in a tunnel, in a greenhouse, so that you get the required temperatures which are required by the fish. Our fish to grow or feed to optimum and grow to optimum, we need temperatures of between 26 and 28 degrees. You can easily get them in a tunnel. At times we can open the vents of the tunnel to allow fresh air to come in if the temperature tends to be more than what you require. So when you open, fresh air comes in, it drives that hot air out, and if that happens, then the temperature in the tank tends to go down to a level which is required by the fish. Then you can go do the process all over again. Let me hasten to say that if you do your fish in a greenhouse tunnel in this system, you can harvest your fish in 5 months. Remember, it depending on the customer, but when I say 5 months, I'm talking of things which we have done, and I can prove that you can do them in 5 months and harvest at 500 grams. So let's turn to the tank. This is our main tank. In all essence, we don't call this thing a tank. It's a system. It's actually a fish system. We call it an aqua production unit. But this is our main tank. Our main tank has got 4.2 meter diameter, and it's a 10,000 liter tank. In this tank, you can do up to 3,000 fish from fingerlings to harvest. Provided you are doing the sex reversed fish, you can do 3,000 from start to harvest. To our customers, if the customer is new, we would recommend the customer to start by doing 2,000 first crop, and you learn. And remember, when you are learning, you learn together with us. We'll hold your hand, and we will go through with the farmer from day one of pressing the fish until harvesting, like telling him when to feed, how to feed, and the like. So from that day 1 to 5 months, you can easily harvest your fish at 500 grams. So to start, you start with 2,000. Learn. If you fail, we'll help each other until you harvest. Then your second crop you would have learned. Then you can go for 3,000. So this is our main tank, right? From the main tank, we then go. I said it's the system. From the main tank, we go to filters, right? We've got our mechanical filter number 1. Right, in this filter you have got brushes. The brushes, the water circulates from the main tank into the filter, then to the second filter, to the third filter, and back into the main tank. There are brushes in the filter. You can see the brushes. The brushes are actually meant to catch all the dirt from the fish residue or any extras in the feed, which which could have not been eaten by the fish. So it is supposed to be caught in this tank. And from this tank, we then go to the next tank, which is a biofilter tank, right? We have got this. We call them wheels in Zimbabwe, but we tend to import these. These filters are then used in this tank. Whatever would have passed the first tank would go into the second tank. If you look at where the water comes in and where it gets out, in between is where all the residues are kept. And this tank is always dormant until we activate it. And we can only activate it when we are cleaning the system, of which I will show you how to clean the system. Then we go on to the, I would say, to the last tank. In this tank, it is where the ammonium which is produced by the fish waste is broken into nitrates. Or in simple terms, it is where the ammonium is broken to a level where if it goes back to the tank, it won't kill the fish. So at that point, at this point, when the water leaves this biofilter number 2, the water will be safe even for drinking, despite the color, but you still can drink the fish, the water, then it goes back into the main tank. So it's a question of recycling. So in terms of the water usage, we only use 80 to 100 liters of water in a day. If I may show you how we flush, because remember I talked of this tank holding on the residue or the dirty from the fish, and this one as well. So every morning what you only do is we close the water from coming from the main tank into this filter. Then we close the water from coming from this filter into the main biofilter. Then we open the bore valve. What we then do every morning, we need to flush the system so that we catch all the dirty in the main tank and we throw it out. But we just don't throw the water away, because it has got a lot of nutrients in it. So at the end of the day, if we flush, we would rather have where we will collect the water and use it in the garden. I would demonstrate now. You close the water from coming from the main tank, and you close so that it doesn't flow from this tank. I told you it is always dormant, but when you are flushing, you make it active. So you close the bubbles from that tank and push them into this first biofilter. And if the bubbles start happening there, say for 2 minutes or so, you then open the bore valve to release all the water from that tank, and the water would look green, meaning nutritious for the plants. You can then irrigate with the water. We have got these pumps. Usually our system would work with 2 pumps. The other pump puts air into the aerator, into the tank, and the other one would then put air onto the air valves. So we have got air valves here where we are putting oxygen. We are actually the system would work on its own because it's putting oxygen on its own. It's circulating the water because we have got a pump right at the bottom, which then sucks the dirty from the main tank through the system and back again. So we are using these 2 pumps. That's why I said you need to use solar, because you can easily get 350 watts from solar. So you can do this system even on a rural setup where there is no ZESA, using solar system. What I'm talking about is already we have got customers who have got these 2 tanks, where the customer with 2 tanks he harvested, we have got records that he made his money. So in terms of feeding your fish, our recommendation is you need to feed your fish at least every 2 hours. But in terms of how much you feed, it depends with it's now between the farmer and the fish. Majority of our stock feed, we get them from profits. In fact, everything we get it from profit, and the majority of it is floating. So as you feed your fish, the feed will be floating. But if it is not taken, if it is not eaten by the fish for some time, it will end up going down. And if that happens, then it becomes toxic. That feed becomes toxic, and it might end up killing your fish. So you feed your fish while you are there. Maximum within 4 minutes, you should be done with feeding your fish. So every 2 hours you come back. When you come back, if the fish happen to be rushing for the feed, you keep on giving them. But if they slow down, then you stop giving them. Then come after another 2 hours. So in all essence, we are saying you can feed from 6 to 8, but not in the evening. But if you so chooses, we don't want them to be like broilers. So you feed them up to 6 o'clock in the evening, and you are done on that particular day.
My name is Sokonia Kaitano. I'm from Blue Chip Fisheries International, an aquaculture consultant company. I'm here to present on fish farming on the model called cage culture. Cage culture is one of the most important model that farmers are supposed to use because of its various advantages. If you look at the frame, we've got a circular HDP cage model. The frame is suspended on the surface of the water, but underneath the water, there are some nets attached to the frame. And in those nets, that's where the fish are kept. This is what we call cage culture, farming of fish in big or large, vast expanse of waters like dams, lakes, oceans, etc. We have another model which we designed as Blue Chip Fisheries International to meet the small to medium enterprise farmers. You can see that this model type is made of a different material from the first one. The first one was an HDPE quality type of a cage, but these ones we use the steel material. And if you look to it, you will find that it has some very small floaters, like the 20 liters plastic floaters, and it comes with 3 types of nets on it. The inside nets, which we call the fingerlings nets. The second net is what we call the grow out nets, which we call the juvenile nets. But the outside net is what we call the predator nets. On that schedule, you can see that we've got anchors that pulls the nets down. Why pulling the nets down? We want to make the net meshes open very wide to allow water circulation. Therefore, the reason why we are emphasizing cage culture, we understand that water is the key component for fish farming. But we are blessed in this nation that we have quite a number of water bodies. Over 10,700 water bodies as per research that we are blessed with in this country. And those water bodies are not maximally used. For your information, we have only 4 dams in Zimbabwe, including Lake Kariba, that are being used by fish farmers, meaning all other dams are not used. This is our emphasis, that as we have plenty of water in Zimbabwe, we need to take advantage so that we can create employment. It's very possible. We can have food security for our nation. It's very possible. At the same time, even increasing the foreign currency incomes. We have the objectives that we want you to understand, that Upon completion of this presentation, we expect the audience to be able to define what cage culture is, to be able to appreciate what cage culture is all about, to be able to evaluate self-knowledge and understanding of cage culture production technologies, methods of operating, and impact on the environment. Able to apply the acquired cage culture strategies to starting up fish projects. Therefore, what is cage culture? This is an expedient water-based method of producing fish and one of the most productive. It consists of floating framework units with mesh nets suspended in water, either seas, lakes, or communal water bodies, with cage sizes ranging from 1 cubic meter to 1,800 cubic meter volume size of a cage. They come in different dimensions. Fish can be stocked at different sizes and stocking densities. We want to talk of advantages of cage culture. One advantage is mobility. They are mobile. Number two, they use the existing water body, so there is no need for water conveyance. You don't need to bring some pumps. You don't need to have some aeration facilities. As long as you've got that water body is enough. What you need to put on it is the infrastructure for the cage. It's easy for waste management. It allows high stocking densities in cage culture. For example, when at normal, you can stock from 25 kgs per cubic meter up to 42 kgs per cubic meter, depending to the parameters that are found in that water body. It's easy for stock management and also good water quality and favorable aquaculture parameters. As you understand that in fish farming, water quality is key. What then are fish cages? We must come to understand what are fish cages. If you look to the screen, these are structures that are suspended in water, are made to float but anchored at one position, made from different materials as its frames. You can use iron steel, HDPE material, plastic material, wood, even bamboos. It depends which material you have to your disposal. They come with the nylon or HDP nets as bag nets, compartments of cage walls to hold fish. They come with the walkways to allow cage attendants ability to carry their duties on cages. Almost they'll spend the whole day, 12 hours on the cage. So they must work on the cage whilst they're doing their daily activities there. The cages must be double framed so that the inside frame must have the bag net, the outside frame must have the predator net. Forms and types of cages. We have got the circular HDP model cages. We also have the steel pipe floating cages. We have the square or rectangular HDP pipe floating cages. We have the square or rectangular steel pipes or angle iron floating cages, square or rectangular wooden floating cages, or pen cages. If you look to the screen, you would find on the images, those are the HDPE quality circular cages. They are double framed circular in shape. the material floats. You don't need to look for other materials to float. They are good on large water bodies, even in the seas or oceans. They can do well even on heavy storms. Very strong, those quality of material. They are hydraulic powered plastic welding machine, which are used to assemble those cages. They have the brackets to hold the pipes so that they remain intact and strong. They have stanchions and rails. They are durable with plus 30 years lifespan or more. They are not corrosive. And we have the other model using the same HDP quality material. You can shape your material to come to square models or rectangular models. They are also double framed cages. They have the brackets, stanchions, and they're durable. They do well on heavy storms, and they're not corrosive. This now is the SME model steel cages to allow the SME farmers to also manage. Almost the other qualities materials are a bit expensive and are not found easily. But using the steel, they are found even local. You can use deformed bars and angle irons to make such cages. You can use 25 to 30 liters plastic flotation. That detached model type cage, you can detach them. Of course, you cannot put a walkway, but they are so small, you feed whilst you are outside. And they can carry not more than 500 kgs of fish harvestable. And their lifespan is over 7 years and suitable for smaller water bodies. These are also steel pipes attached cage models. If you look to them, these can be used by large commercial farmers using this type of model, but a number of them tied to each other, made from round steel or galvanized pipes. You need to use 210 liters or 235 liters of flotation, those plastic drums. And you put some walkway so that the workers on the cages would have way to walk on when they're doing their duties. Can also do well on large water bodies. Almost they're made from strong materials. And they can last plus 15 years and are easily dismantled. You can shift those cages from one dam to another by detaching them. If you look to the screen, we have various cage types, which Blue Chip Fisheries International is trying to encourage the farmers to go on. To the first slide, you will find that there is a circular HDP pipe, and that one we call it an elephant circular weld semi-safety cage. Why elephant? Only because the stocking densities are high. You can put you can harvest about 100 to 120,000 metric tons of fish, 100 to 120,000 fish in that HDP cage, meaning something between 35 to 40 metric tons in one cage. That's why we call it an elephant circular weld semi-safety cage. The second one is an Exodus semi-safety cage. This one is a double frame. It minimizes only the costs in the infrastructure, and you can find that it's a double cage with 2 compartments. The first one is the Genesis one, on both is just a single cage type of model. If you look to the fourth one, that one is a plateau type. It has got 4 compartments attached to each other. And we've got the Lock It Linear Series semi-safety cage, only because it has 10 cages attached to to each other. That's why we call it lock-it linear series semi-safety cages. And the last one is the Scotland linear series safety semi cages. Almost it has about 20 of cages attached to each other. So these are the models of the cage types that you farmers can take advantage of using our dams. You cannot do cage culture without one of the most important components. Blue Chip Fisheries International managed to design what they call a multi-purpose access rafter boat. Why a multi-purpose? We understand that the small to medium enterprise farmers, they are starting and they don't have more money. So that for them to buy different boats. Because of this, Blue Chip Fisheries have designed for you a multi-purpose access rafter boat, which is in one boat. It's your transport boat, transporting you from the shoreline into your cages. It's your transfer boat where you use it to transfer your fish from one point to another. It's also your harvest boat where you can use to harvest your fish into the boat to your shoreline. You can use it as a security guard room during the night. On boats, we need people to be on the cages 24 hours. And it's your storeroom that you can put your feed to use on the cages. And at the same time, it's an office for the cage attendants where they keep their records, their books, and other important tools and gadgets to use on the cage culture. Cage culture models. The small to medium enterprise cage culture models, you can start from an extensive, which is a subsistence type of a cage. And 400 kg cage to 1,000 kg cage is under an extensive or a subsistence type of a farmer. And that one is only an 18 cubic meter cage to a 32 cubic meter cage. Then a semi-intensive type of a cage model, it's for the starters but going into commercial. Those are the farmers that now doing plus 1,000 kgs to 10,000 kgs. And the cages are from plus 32 cubic meter to 320 cubic meter size of a cage. Then we have the intensive, which is the commercial one. Those ones, they harvest from about 10,000 metric tons to plus 100,000 metric tons of fish. And they need bigger cages or volumes of around 3,120 cubic meters. Therefore, the SME model cages must not have a volume of more than 320 cubic meters. On both their SMEs, they don't have the big machines that they can use on the operations. But on the large-scale cage culture models, which is an intensive one, which they use even the machines when operating big boats, when doing their operations, they also harvest more biomass. So they need to have cages that are around 1,800 cubic meters and above. When you are constructing cages, you also need to consider the materials that are used for cages. You may use HDP materials, you may use wood, you need aquanets, that is the 80mm mesh for fingerlings, you need the 10mm to 12mm mesh for the grow out nets. Fish, you need also the 16mm up to 24mm mesh size for the predator nets. You need some materials to use of your choice when you are constructing cages. You may need steel materials, you may need HDP materials, you may need wood materials. You also need aqua nets. Those are the 8mm mesh type of nets which we use to hold fingerlings. You may need 10mm to 14mm mesh nets which we use for the grow out bag nets. We also need 10mm to 24mm mesh size nets which you can use for predator nets. Then you also need the 30mm, 32mm mesh for bed nets to protect your fish from birds. Then you need the harper nets or the mosquito nets type, which you need to use as feed traps so that you can not allow your feed to be washed out of the cage into the dam. You also need ropes, the polystyrene quality type of ropes from 6mm to 32mm size, depending to where it is applied. You need also plastic floaters, steel floaters, or HDPE pipes that floats. You need wood, expanded metal, HDPE or plastic walkways materials. You need net anchors either from concrete or non-steel weight object, approximately 2.5 to 3 kgs for the cage net anchors, and you need also the cage anchors depending to the water exchange that is in the water body that you are using. But you can use something more than 200 kgs per 1 cage anchor, 2 tons, depending to how big the water body is and how big your cage models are. If you look on the screen there, you would find that there is a woman here who is putting a feed trap on the grow out net. All cages, they demand feed traps to prevent feed from coming out through net holes. So you need to use a 40% harper net of any color. The feed trap must not be more than 0.5 meter deeper from the water level. And this is a demonstration of a cage net dressing. If you look, that cage which is put there where the tent is the complete 5 meter by 5 meter cage model. You can see the frame on top. You can see on top of the frame there is a bed net cover there, and you can see on the walls there are some nets around it. It's just a demonstration so that you can see how the cage is being dressed. If you look also to that frame, you will find that that one is a HDP circular cage model, and this is how it is. And you can look the ropes anchoring that cage going down into the water. That's an example of a grow out net. That's a demonstration of the fingerlings carried with an access multi-purpose rafter boat from the shoreline into the cages for stocking. You can see a demonstration of people there on the cages. They have stocked their fish and they are now acclimatizing their fish, waiting for the period of 15 to 30 minutes for them to adapt to the climatical new condition. That one now, we are demonstrating that when you are doing cage culture or fish farming, you need a dissolved oxygen meter that you use to measure the dissolved oxygen and the temperature for the water. So how do you do it? When that circle is a cage circle, that square is a cage which is square. But when you are taking your DO meter, you take DO meter out of the cage from the windward side, then you take the DO meter from inside the cage, then you take the DO meter from the leeward side of the cage. Why do we do this? When you see that the DO meter inside the cage is lower, but the DO meter from the windward side or the leeward side is much better, it shows that your cage might have a problem. It could be the net is clogged, maybe because of the cloudy cover or decomposition of waste or feed that is causing the depletion of oxygen. So this is how you need to take your DO meters every time you are checking dissolved oxygens and temperature. Also on this image, you can see that salt is an important product again that we use as medicinal when we are doing fish farming. But how do you salt bath your fish which are in the cage? Because the water is too much and they cannot feel the concentration. So what you do now, when you just look to the images, you do find that we've put some small cages of salt which we tie on the rod and we suspend them on the water in the cage so that they won't go deeper. Why? We want the concentration of salt to be felt right on the surface of the water. So when you stock your fish, the fish will swim to the bag of salt. When they feel the concentration of salt, the fish will continue now swimming around that bag. So you will be helping the fish by reducing stress. You will be helping the fish by healing the wounds if they have got some wounds. You will be helping the fish by killing bacteria if there is any bacteria. And at the same time, trying to balance salts in the fish. I think on the presentation on cage culture, this is more about cage culture. And I'm very happy that you have listened on the presentation, and it's your time now to take a decision what you want to do with this model.